Hello everyone! Now in this video we're going to look at the workflow of reworking a part on our BLOQ4 mill. Well, you see these 4 holes here on this part of our torque lathe. I totally forgot to design them when I ordered the part. So we have now to rework them on our block mill. On our BLOQ4 to be more precise. You see here that I set the 0, X, Y and Z on this hole on the left lower edge on the screen. Then here I check the feeds and speeds on another part that I already have done in steel. And then I'm now doing the tool paths. It's very simple. It's just 4 holes with 2 different sizes. Here you see the simulation. Very simple. And now we are on the machine. It's already homed. We see here the part. The 4 holes are missing. The part is now aligned on the table to be perfectly parallel to the y-axis. For this I use a dial indicator. Now you see the 3D probe is already mounted and I'm moving now the 3D probe exactly over the hole that we chosen as reference point on the manufacturing part of Fusion. You can, of course, if you want to mill something, you don't really need any of this. You don't need a 3D probe, a C-setter or a tool setter. You can just set the zeros, the X, Y and Z by hand. This would be no problem. You see now we're probing the hole to find the perfect the middle point of the hole, or the center of the hole. Yeah, that's the word. Perfectly, we have now found the center and I'm moving up the 3D probe and I'm removing it. And now you see the C-setter. This is to find the C0 of the C-axis. But first we do the tool reference. So the machine knows how long the tool is that's in there. And that is now finished. And now we move on to the setting the 0. Yeah, we choose standard block 0 and we set the correct height of the C-setter, and then we move the end mill over the C-setter and we click probe. Yeah, we choose only C and we click probe. Now we wait for that to finish. Perfect, and now we have found X, Y and Z zeros are now perfectly in the middle of the hole that we choose as a reference. And the C is exactly on the surface of the inner part of this part. I'm now going to X, Y and Z0 to reference by eye that it's all correctly set. And now I'm turning on the air and clicking start. This is only milled with a little bit air, so no flood coolant now, because the part is very long and it overlaps the machine on the front and it will be all on the floor. Yeah, we can now see the top part of the hole. It's a little bit, it doesn't sound as good. I think the feeds and speeds are quite off here. So yeah, I only guessed it. The lower part, not that you hear now, sounds much better. You hear almost nothing. The whole machining time was around 5 minutes with 1 degree pitch down. I think if we do like 2 degree pitch, we can shorten the machining time probably to around 2.5 minutes, and even lower. Would be no problem with this machine. Yeah, the machining is now finished and we move on to the chamfers. We could also do this with the machine, of course, but for 4 holes it's much easier to do it by hand. Takes like 10 seconds and no tool change. But the tool change would now be very easy as we have the tool reference length. So we would only need to put in another tool and then click reference or tool setting, and then we can click resume and it will finish the program. Now we can check at the finished part and it looks very nice. The walls of course also look very good. And yeah, it's in 45 steel and it came out very nice and it was very fast. Yes, this is the finished part. And now we can also see it mounted on the lathe. It fitted perfectly. Okay, hope you had fun.